Welcome to 8th lecture in second chapter in our comprehensive course on machine learning, data science, and deep learning and artificial intelligence. Now, in this course, we are at present doing this thing, that is the types of operators in Python. Previous, we have done various data types and we did detailed discussion in previous two lectures. Now, operators. So, in Python, arithmetic operators are there, relational operators are there, assignment operator is there, logical operators are there, bitwise operators are there, membership operators are there, and identity operators are there. And below here, we will do detailed discussion of all except this bitwise. We will take bitwise also later on, but these are at least easy. First, about arithmetic operators. Here it is very clearly written that arithmetic operators, as the name indicates, are used with numeric values to perform common mathematical operations. What are common mathematical operations? Obviously, addition, subtraction, multiplication, division. In other, there is a slightly advanced mathematical operation called modulo. Or modulo is finding the remainder which remains after the division process, and exponentiation, that is finding the power, and floor division or integer division. Whenever we divide one number by another, it is not always necessary that the answer is a whole number. It may come out to be 3.5. Then the floor division will give answer only 3. It will ignore the non-integer portion. That is why floor division is also often called integer division. Now let us take some example. This plus, minus, multiplication, these are all called operators. And on either side, these 5 and 2, 5 and 2, these are called operands. Okay. And here I have taken simple cases, 5 plus 2, because for arithmetic operators, the operands must be just simple numbers. So then 5 plus 2, then b equals 5 minus 2, c equals 5 into 2, d equals 5 divided by 2. So up to this is very easy. Obviously, a will be 7, b will be 3, c will be 10, and d will be 5 divided by 2, it is, so 2.5. When you do ordinary division, at that time, it will give answer along with a decimal point. But now here it is written 5 and 2 times divided symbols, that is called that floor division or integer division, and there, as I say, 5 divided by 2 will be 2.5, but this is a floor division, so it will give only the whole portion or the integer portion, that is 2. So the answer of this should come out to be 2. And then this is 5 modulo 2. So it gives remainder of what will remain after you divide 5 by 2. So 2 2s are 4, and obviously 1 will be the remainder. So f would be 1, e would be 2.5, e would be 2 because it gives only the integer portion, d would be 2.5, c should be 10, d should be 3, and a should be 7. Let us print and check it. And two semicolons are there, sorry. Okay, so you get all expected answer. First is 7, next is 3, next is 10, next is 2.5. Now here, these two are worth seeing. 5 integer division 2. So it gives only the whole portion, that is the only the integer portion. It ignores the portion after the decimal point, that is it ignores this 0.5. Okay, and 5 modulo 2, as I said, it will give the remainder. So 2 to the 4 and the remainder is 1. Okay, so it is very easy. Arithmetic operators are very easy. Now comparison operators. Here the sign is either equals or exclamation equals, which is called not equal, or greater than or less than, or greater than or equal to, or less than or equal to. Okay, so this is the one example which we are taking. A equals 5 multiplied by 3 and b equals 5 multiplied by 4. So a will be 15, b will be 20. First I am trying to see what will be the result of this. A equals b. That means are these two numbers equal? So obviously they are not equal. So this should give me false, because my two numbers are not equal. Now then next time I am trying to print a is not equal to b. So are these two numbers not equal? Then yes, they are not equal. So this means this statement is correct. So this should print true. Now print a greater than b. So a is only 15, b is 20. So therefore a greater than b, it will not be very correct. Okay, so that means this should give false. And is a less than b, so 15 is less than 20, so that should give true. Let us print, and you can see a equals b, that gives false. A is not equal to b, that gives true. A greater than b, so 20 greater than 15 greater than 20, so obviously it is false, so it gives false. A less than b, 15 less than 20, so that gives true. Okay, now logical operators. Logical operators are used to combine the conditional statements, and two logical operators are used, and or not. Okay, and sorry, three logical operators, and or not. And combined conditional statements means what, that you should understand. Here this is operator, and on either side there are two operands. Now here I have written directly the outcome of the condition, but instead of this true, there would be some conditional statement like say 5 greater than 3. And here also there would be some other conditional statement like say 15 greater than 13. So if you do it that way, then this is also true and this is also true. So then the output of both truths, when you AND them, that will give true. But AND is has a condition that for it to give true output, both operands must be true. So here this is true and this is true, but so outcome of first statement, this whole statement would be true. But in second case, still the operator is AND only. But on the left side, the conditional statement evaluates to true, and on the right side it evaluates to false. For example, here I have written 5 greater than 3, so it will evaluate to true. But here I have written 2 greater than 5, so it will evaluate to false. Then AND requires both sides, both operands to be evaluated to true to give final answer of everything to as true. But here in this case, one operand evaluates to true, but the other operand on the right side of AND that evaluates to false. So that is why answer should be false. So the first answer should be true, second should be false. Third, OR operator. Now OR operator is a slightly relaxed condition compared to AND. AND requires that these also must be true and these also must be true. Okay, so like this. But OR requires, as the word itself indicates, that either this operand must be true or this operand must be true. Any one on the left side must be true or on the right side must be true. Other can be false, but the whole expression, this whole expression will evaluate as true. So outcome of this should be true. And not true just negates whatever is given to you. So that means not true. So that will give false. And I can add one more. Print not false. So not false, then obviously it is true. So now what I am expecting, that this whole expression should evaluate as a true, because on both sides of AND operator there are true. Okay, these expressions should evaluate as false because AND requires that both sides must be true. But here one side is false, so this whole will evaluate as false. These will evaluate as true. These will evaluate as false, and these will evaluate as true. Okay, so let us run that, and you can see same answers are obtained. True and true, that gives a true answer. For true and false, that gives false. True or false, that will give true, because for OR operator any one side is true, that is enough. Then not true, that is equal to false, and not false, that is equal to true. So this is a very nice example which shows the beauty of Python language, that how closely it is resembling our ordinary English, that not true is false and not false is true, and true or false, then it is the answer will be true, like that. But now here what I was saying is that here it is written that logical operators are used to combine conditional statements. So now let us try to put some actual conditional statement. On the left side true, say 5 greater than 3, and on the right side also true, say 7 greater than 5. Then here on the left side true, so again I am putting 5 greater than 3. But on the right side false. So I will write 7 less than 5. Obviously that statement will be false. 7 less than 5 is false. Now then true or false. So at that time I will take again these two statements only. So 7 less than 5, that I am taking here a false statement, and 5 greater than 3, that is a true statement. So that I am taking here. Okay. Now not true, so not 5 greater than 3, and not false, so not 7 less than 5. Now let us try to understand each. This says that 5 greater than 3, so it will evaluate to true, and this says that 7 greater than 5, so it will also evaluate to 2. So true and true, so on both sides are true, so AND operator requires that, and we have fulfilled the condition, so answer should be true. But here this says 5 greater than 3, which is true, but 7 less than 5, sorry 7, okay, less than 5, that is false. So that means that true and false, so we are not satisfying the condition that on either side of AND both should be true. So we are having false here, so obviously the answer which AND operator or this whole expression will evaluate to will be false. Then here now OR operator. For OR operator, any one on one side should be true. So at least this is true. Though this is false, that is fine, but this 5 greater than 3 is true. So this will evaluate to true. Now not 5 greater than 3. So even by English also it is clear, not 5 greater than 3. So obviously it is true, okay, and 5, sorry, it is false. 5 is greater than 3 and not 7 less than 5. So now 7 is not less than 5, that we know, and here also it says not 7 less than 5. So that is also, that will come out to be this 7 less than 5, that will be false statement, and this is not a false, so that will come out to be true. This 5 greater than 3 is condition will evaluate to true statement, and when you add it is not, then not a true, so that will be false. So that means result should remain same as what we got earlier. Okay, so true, false, and true. Okay, so this is what is meaning of logical operators are used to combine conditional statements. Okay, and these logical operators are very important. In fact, all these are important, but logical operators are very important for designing program logic. Okay. Then these are assignment operators. Now, assignment is, say, very simple thing. A equals 5 means assign this value A, sorry, assign this value 5 to this variable A. Then name equals Tejas means assign this value Tejas string to this variable name. Now, up to that things are easy, but here it is written A plus equals 5. That is just a short form preferred by programmers to write this thing in a succinct manner. What does this mean? A plus equals 5 means whatever is the value of A before this statement, add 5 to that statement and assign that new value back to the A. So that means here in A, whatever was the value of A before this statement, add 5 and assign that value to A. Similarly, A minus equals 3. That means whatever was the value of A before this statement, subtract 3 from it, minus 3, and then assign the value, new value back to A. Then A multiplication equals 3 actually means A equals A multiplied by 2. So whatever was the value of A before this statement, multiply that by 2 and assign that value, new value obtained to A. And similarly, whatever is the value of A whatever is the value of A before this statement, divide it by 7 and multiply it by assign that new value to A. Okay, let us see what will happen even before executing. We try to calculate orally. A equals 5, print A, so answer would be 5. Then this will print Tejas. Now here A equals A plus 5, so that means 5 was the value before this statement. So add 5 in that, and now A will become 10. So this print A, that should print 10. Now again A equals A minus 3. So before this statement A had already become 10. Now subtract 3 from it, so A has now become 7. So this print statement should print 7. Now A equals A multiplied by 2. So that means whatever was the value before that statement, that was 7 multiplied by 2. So 14, and 14 will be assigned. So this print statement will print 14, and then A equals A by 7. So 14 divided by 7, so 2, and that 2 will be assigned to A. So this print statement should print 2. Let us see if it is correct. So yes, first is printing 5, next is printing my name, but next thereafter, what original value of A was 5, but 5 are added, so 10. Now original value is 10, but 3 are subtracted, so 7. Now original value was 7, but multiplied by 2, so 14. Now the original value was 14, but divided by 7, so 2. So this is just a short form way of writing. If you are completely new to programming, then I will advise to stick to this method of writing. Okay, rather than this short form or succinct way. But if you are already coming from some programming background, then you can use this shortcut method. Okay. Now membership operator. Membership operators. Now membership operators are used to test if an element is present in a sequence. For example, there are two membership operators. One is in and another is not in. Okay, and I can do a very simple example case that let us write 3 statements like this. 5 in the list 1, 2, 3, 4, 5. So 5 is in that list, and therefore this statement will evaluate as true, and therefore here it should be true. Okay, don't look at the old values. Let me clear the output. Then 6 in 1, 2, 3, 4, 5. Okay, so that 6 is not there, so this will evaluate to false. So second should print false. 6 not in this, so 6 is indeed not in this, and therefore this should evaluate to true. So first true, second false, and third should be true. And you can see that you get that kind of output. Okay, now identity operators. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. Now this is important. So identity operators are slightly special type of operators. There are two operators, is and is not, and they compare whether two given objects share the same memory location or different memory location. And one more thing which I would like to write about this identity operator is that use them only for complex data types. I am explaining what is that complex data type. Do not use them for primitive data types. Okay. So what does this mean? Here we have seen various data types earlier, somewhere here. So this integer, this floating point, then this string, these are called primitive data type. A equals 5, A equals stages, all this. While this list, which is made up of several integers element, this is called complex data type. So this is a single element, primitive data type. This is also a single string, so primitive data type. This is also primitive data type. So these are all simple or primitive data type. But when you write a list or a tuple or a dictionary, these are all called complex data type. Now the point of finding that memory location using our these operators, our operators are here, is operator and is not operator. Okay, so they are useful only for uh, complex data type, not useful for primitive data type. Say A equals 5 and capital A equals 5. Now that means clearly these are two different variables. Okay, but if you write A is A, then Python here will give true answer, because that does not mean these two variables are equal, but these two variables, their values are stored at same memory location. And if you write A is not A, then Python will give false as an answer. So because the values are stored at same memory location. So for simple or primitive data types, the behavior is that once the value is equal, then irrespective of whatever is the name of variable, they are stored at same memory location. Okay. So this is one thing. Second example is these also. Again, the values are equal. This is a string data type, name 1 and name 2. And these are two different variables that we are trying. But ultimately, if you write name 1 is name 2, then both name 1 and name 2 will be stored at same memory location. And name 1 is not name 2, that will give false, while here this will give true. If memory location is same, then is gives true. If memory location is different, then is gives false. Let us execute. And for string also, that means it is not advisable to use these identity operators. Then where they are useful? They are useful for complex data type. Here if you test this behavior, say this is a list 1, 2, 3, and this is a list 1, 2, 3. This is assigned to one variable L1, and this is assigned to another variable L2. Compare with this case. But here this is basic or primitive data type, this is a complex data type. Then Python handles complex data types in a different manner. Even if the value or the two lists are identical, still it will assign a new memory location for each instance of that list. So here if I write L1 is L2, that means basically is the memory location of this list and the memory location of this list same? Then no, Python will allocate different memory location. If you add another list L3 equals 1, 2, 3, then still third memory location will be allocated. Okay, so you should L1 is equal to, here it will give false, and L1 is not L2, that will give true. And you can see that is how it is. Now for tuple also, it is a complex data type, and T1 is 1, 2, 3. I could have written T2 is also same 1, 2, 3, but instead of that I am writing T1 is equal to T2 equals T1 dot copy. Now this type of operations we would be be doing several times in various code snippets during our data science functions and all that. So that means I am actually copying this tuple and I am assigning its value to this new function. But when you copy, then also it will assign the same value 1, 2, 3, but it will give a different memory location. So this says that is the memory location of T1 same as memory location of T2? Then no, but they are not the same. Okay, so oh sorry, I think for tuple the copy attribute is not there, so perhaps I would have to do the same thing for list only. L1 equals 1, 2, 3. But copy is important because we will be using it several times. So you should understand that copy command creates a copy of the original element but in a different memory location. Yes, now it can be seen that is memory location of first and second list equal? Then no, it says false. That means they are different. And is memory location of first and second different? Then it says yes, they are different. So what I am saying is that this is and is not, they are same operators, but they behave differently based on whether you use them for primitive data type and whether you use them for complex data type. Okay, and normally they are not used for primitive data type. Now what is happening here, I can show by a diagram also. So this is the diagram. Actually, I have drawn using my mouse. So apologies for not very nice handwriting, etc. But when you use that simple data type, one string was attached to name one. Name one equals in quotes stages, and then name two equals in quotes stages. But in both cases, you got the same memory location. So Python is intelligent enough for primitive data type that if values are equal, then it will not waste memory. It will store in the same memory location. It will just create new kind of pointers. Okay. Now, then similarly here, small a and capital A were two different variables, but both wanted to we assign value 5 to both. Then Python is intelligent that why waste two memory locations, keep 5 in both and assign pointers. But when it comes to complex data type like two lists, I have L1 is equal to 1 to 3 and L2 is equal to 1 to 3, then in that case it will not work. Okay, though both are same list, identical list, here Python will allocate different memory locations to them. Okay, so that you can easily, because we have learned that lists are mutable, so you can change the value of L1, but still the value of L2 will not change because it is at a different memory location. So this is one important thing. Okay? This thing for tuple, we saw that that factor is not there. But even if there are two tuples like T1 equals 1, 2, 3, and this time I try to create another tuple T2, not by copy command because that failed as we saw, but by explicitly creating it. Okay. So let us try what happens. It shows again that T1 is having same memory location as T2. Is it true? Then no, it is not true. So that is what that diagram also showed. I cancelled it on my here, but I should not have done that. Okay, so for tuples also, even though tuples are identical, Python will store them at two different memory locations. Okay, so this is about this operator, that is identity operator. So we have discussed, if you see this diagram, then all